Hello, welcome. In this short video, let us look at some examples illustrating how to use laws of probability to calculate probabilities of events. So look at example 1. Consider an experiment in which we have a computer code. Our goal is to observe the computer code and note that whether the code is either long or short, and also how much time does it take for execution. So the sample space consists of 4 possible outcomes. That is, the computer code is either long and fast, it could be long and slow, and it could be very short and takes very little time, and also it could be very short but takes very long time for execution. So here B stands for long source code and L stands for small source code, and F stands for a fast code, that is, it takes very little time for execution, and W stands for a slow code, or it takes very long time for execution. So this is the sample space. Now we are given the following information, that is, probability of the outcome LF is equal to 0.5, and probability of the outcome VF is equal to, that is a code is long but takes very little time, is equal to 0.2, and we are also given that probability of BW, that is a long code but takes very long time for execution, is 0.2. Now we want to find different probabilities. The first one is probability of LW, that is a source code is very short but it takes very long time. By using the law of total probability, that is probability of the sample space is equal to 1, and it is also equal to the sum of the probabilities of individual outcomes, that is P of BF plus P of BW plus P of LF plus P of LW. So the probability of LW, that is code is short but takes very long time, is equal to 1 minus, that is probability of the sample space, minus the sum of the rest of the values, that is P of BF plus probability of BW plus probability of LF, which is equal to 1 minus 0.2 plus, and probability of BW is 0.2 and probability of LF is 0.5. So this is equal to 0.1. So we now know that probability of LW is equal to 0.1. Thus we can use the law of total probability, that is the probability of sample space is equal to sum of the probabilities of individual outcomes. So we can by using this law we can calculate the unknown probability, that probability of LW. Now let us look at another probability, that is probability of W. How do we calculate the probability of the event W? Since the event W consists of 2 possible outcomes, that is probability of the events BW, the outcomes BW and LW. So the probability of W should be equal to probability of the constituent outcomes, that is probability of BW plus probability of LW. So we know that LW is 0.1 and BW is given as 0.2. So the probability of W, that is the code is slow in terms of execution, is equal to 0.2 plus 0.1, which is equal to 0.3. And similarly, we can also calculate the probability of a union event, that is probability of the event W union with B. That is, a source code could be either slow or it could be very large. That is, the probability will be equal to sum of probability of W plus the sum of probability of B minus the probability of W intersection B. So we just calculated that the probability of event W is equal to 0.3. Now we need to know the probability of event B, which is equal to the probability of all the outcomes in which the code is very long. So it is equal to probability of BF plus probability of BW. And we know that they are both equal to 0.2. So the total probability is 0.4. And now we have to find a probability of the intersection, that is probability of W intersection B. So this intersection has only one outcome, that is probability of BW, which is known to be 0.2. So the probability of the union, that is the source code is either slow or long, is equal to the sum of these two probabilities minus the intersection probability, the probability of the intersection event. So it is equal to 0.3 plus 0.4 minus 0.2, which is equal to 0.5. Thus we can use laws of probability for computing the probabilities of different types of events. Thanks for watching.